How does HTTPS work? It is extremely important to understand HTTPS working as applications are getting deployed in microservices architecture on OpenShift or Kubernetes cluster. I will explain the concepts in an animated way to understand it more easily. Netscape. Netscape have started SSL in 1994 to have secure communication between browser and server. Mainly, it was for e-commerce capabilities over the internet. Internet Engineering Task Force (IETF) proposed TLS in 1999, and now TLS is also known as successor of SSL. SSL acronym was so popular that it is still used. Even now TLS is widely used. In order to understand TLS or SSL communication, you need to know how public key cryptography and signature works. It sounds complex, but in a nutshell, it is easy. So first, let's understand public key cryptography. Any message which is encrypted by a public key can only be decrypted by its private key. So let's understand this with an example. Alex has its own private key and public key. Now, a message was encrypted by Alex's public key. And when it comes to Alex, he can use private key to decrypt it. Here, the important thing is only Alex can decrypt it as he has a private key. Others who don't have a private key cannot decrypt it. This is the power of public key cryptography. This was a public key cryptography part. Now let's understand the signature part. Anyone who has public key can verify who has sent a message. This means on internet, if anyone receives a message with a public key, can check who had sent it and is that authenticated. Let's understand this with an example. Let's say Alex wants to send a message to Alice and he has his own public key and private key. He created a message with his public key and sent it to Alice. Now, if Alice wants to verify who is the owner of this message, then she can verify it by using a public key. There is a certificate authority which holds Alex's signature certificate along with public key. The certificate authority verifies the public key and signature. Once the signature is authenticated, Alice identifies who has sent a message to her. This is how signature work. Now let's understand how communication happens on HTTPS. Assume Alice wants to access youtube.com. She launches a browser and sends a request. The request then travels through DNS and reaches youtube.com. YouTube server sends back the certificate along with public key as a response to Alice browser request. Browser accepted. Browser has its own certificate authority listing. It verifies youtube.com certificate against it and identifies who signed the certificate. Once it is verified, then it creates a secret key. This secret key is then sent back to youtube.com. Then youtube.com verifies it and decrypts it with its private key. Now, this new secret key is used in entire communication. In between this communication channel, if hacker tries to decrypt the message, then it will be blocked as there is no private key. Hence, the communication is safe and secure. In previous discussion, we saw certificate authority. What is certificate authority? To understand it, let's start with youtube.com. Now youtube.com has decided to serve request over HTTPS. In order to enable HTTPS on youtube.com, youtube.com has created a public key and a private key pair. There is a certificate authority such as GTS, Google Trust Service, GoDaddy, DigiCerts. These are the CAs who signed certificates for servers. It also has their own public key and private key. To obtain a signed certificate from CA, youtube.com creates CSR, that is certificate signing request, along with public key and private key, and sends them to certificate authority. Certificate authority creates a certificate along with private key and sends it to youtube.com. Now, the browser has all well-known CA certificates such as Google Trust Service, GoDaddy, DigiCerts. Browser can verify who has signed the certificate. In this example, it is signed and authorized by Google Trust Service. So this is how a certificate authority works. Now let's see what is self-signed certificate. Sometimes it might not be necessary to have a well-known certificate authority signs the certificate. There is no third-party authority to sign the certificate. Assume you have your own application on a development or staging server and want to communicate over HTTPS. But the question is, who will sign the certificate? Here, self-signed certificates come handy. In order to create self-signed certificate, the CSR needs to be created and signed. Once the certificate is ready, it can use for encryption and decryption. The browser does not have these locally signed certificate. It shows no secure sign with warnings. As this is local server communication, it is up to you to proceed ahead with it. If you proceed ahead, then the browser will treat it as an unsafe communication. But the certificate does have public and private key cryptography. The communication will be in encrypted fashion. If your goal is to have only encryption or encrypted communication without a certificate, then you can use a self-signed certificate. So, this is all about HTTPS, certificates, public and private key, and how it works. I hope you got helpful information on TLS and how it works.